Hey everyone, our next lesson is going to be on common factors. So obviously common factors are just factors that are the same between different numbers. So our standard is find all factor pairs for a whole number in the range of 1 to 100, which we've been doing the last two lessons. Recognize that a whole number is a multiple of each of its factors, which we'll be working on later on. And determine whether a given whole number in the range of 1 to 100 is a multiple of a given one-digit number. Determine whether a given whole number in the range 1 to 100 is prime or composite. All right, so our first problem is this one. Chuck has a coin collection with 30 pennies, 24 quarters, and 36 nickels. He wants to arrange the coins into rows. Each row will have the same number of coins, and all the coins in a row will be the same. How many can he put in each row? Okay, so what do I need to find? First thing I need to find is how many he can put in each row. Whoa, Miss Finley's writing is very sloppy. Okay, so we want to know how many each row. All right. The next thing that we want to find out is what information do I need to use? So we've got several ways that we can do this. All right. So we've got what information do we need to use? We have 30 pennies, we have 24 quarters, and 36 nickels. So we have 30 pennies, 24 quarters, and 36 nickels. Okay, how are we going to use this information? Okay, so you know that we're working with factors, and the last two we have done was in relations to figuring out which factors make up these numbers, and that's what we're going to do. So you're going to find out what factors are for each number. All right, so these are supposed to be together, but figure it out. Oh, there we go. All right, so we're going to find out what factors are for each number. Now we're going to solve the problem. So we have 30. We have 24. We have 36. Okay, now I want to figure out the factors for each of these numbers. Okay, so that's what we're going to do. So 30 is going to be 1 and 30, right? 2 and 15. What else can 30 be divided by? 3 and 10. Can it go 4 into 30? No, we can do 5 though, right? 5 goes into 30 6 times. 6 is there. 7 can't go into 30. 8, 9, and then we're just going to start repeating numbers of 10, 15, and 30. So those should be the factors of 30. How about 24? We've got 1, 24. Okay, 24 is a even number, so we can divide by 2. 2 times 12. 3 goes into 24 how many times? 8. Okay. How about 4? 4 can go into 24 6 times. 5 can't go in. 6 is already there. 7 can't go in. 8 is already there. 9 can't go in. 10 can't go in. 11 can't go in, and so on and so forth. So those should be our factors for 24. So we got 1 and 36. 36 is also a even number, so it can be divided by 2. 2 can go into 36. If you don't know, we can go 36 divided by 2. 2 goes into 3 one time. bring the 6 down, so it goes into 16 18 times, okay? So we have 18. Let's see if we can get it to recognize that number. Okay, so we got 18. Can 3 go into 36? 3 can go into 36. 3 can go into 3 one time. And 3 can go into 6 two times. So 3 times 12 is 36. How about 4? 4 times 9 is 36. 5 can't go in because it doesn't end with a 5 or a 0. 6, oh, 6 times 6 can go into 36, right? 7 can't go in, 8 can't go in, and then we'll just start repeating numbers. So there is our factors for this. Let's erase our division problem here. Okay, so here we have our factors. Maybe you can see all the rest of them. All right, so what I'm going to do now then is I'm going to go and I'm going to circle the ones that are the same. Okay, so I'm going to circle the ones that are the same. So let's see, we've got 1s are the same, 2s, 3s, nope, no 4s, no 5s, 6s though, 7s, 8s, 9s, 10s, 12, 15. Okay, I think that's all of the ones that we have. So the answer then to my problem, which I'll scroll up so we can see our problem. Each row will have the same number of coins, and all the rows in all the coins in a row will be the same. How many can he put in each row? Well, he can put 1 in each row. So my answers then would be 16 the page. He can have 1 in each row. He can have 2 in each row. He can have 3 in each row. He can have 6 in each row, and that is it. Okay, so we just need to figure out what factors are for each number. All right, next problem we have is Ryan collects animal figures. He has 45 elephants, 36 zebras, and 18 tigers. He will arrange the figures into rows, each row with the same number of figures. Each row with the same number of the same figures. How many figures can be in each row? So what do we need to find? How many figures in each row? Okay. All right, so we need to find out how many figures are each row. What information do I need to use? I've got 45 elephants, 36 zebras, and 18 tigers. Oh, Lord, that's not right. I have 18 tigers. All right. How are you going to use this information? Okay, what are we going to use this information? Well, like the other one, I need to figure out what the factors are. So I'm going to find the factors of each number. All right, let's try that. Okay, so we need to find the factors of each number. This one. There we go. I'm going to do the same thing that I did over on the other problem, right? So here are my numbers. So I'm going to go 45, 45, 36, and 18. Now I'm going to figure out the factors of these. All right, so I'm going to have 1, right? So 1 and 45, 1 and 36, 1 and 18. Okay, how about 2? Can 2 go into 45? Negative. 2 cannot go into 45 because it's not an even number. How about 3? Can 3 go into 45? If I don't know, I can do my division. 3 goes into 4 one time. Extend the page. Bring down the 5. 3 goes into 15. 5 times, so my answer then is 15. So let's put that there. Okay, so we have 15. So that would be 3 and 15. Does it go in 4 times? Can 4 go into 45? Nope, because it's not an even number. I know 5 can, right? 5 times 9 is 45. And I believe that is all for that one. I don't think I can go any further than that. Okay, let's go to 36. Let's erase our division problem down here. There we go. All right, so 1 and 36. 2, can 2 go in? Well, it's an even number, so 2 should be able to go into 36. If you don't know offhand, then we'll do our division. 2 can go into 3 one time. 2 times 1 is 2. 3 minus 2 is 1. I'm going to bring the 16 down. So it should be 18. Okay, so 2 times 18 is 36. How about 3? Well, looking at 36, 3 can go into 3 one time. And 3 can go into 6 two times. So 3 times 12 is 36. 4 times 9 is 36. And we know from the last one, it's 6 times 6 can also go in. All right, let's erase our division problem. And let's take a look at 18. So we have 1 and 18. 18 is an even number, so I know that 2 can go in, and I know that 2 times 9 is 18. How about 3? 3 times 6. 4 can't go into 18. Neither can 5. And so, yeah, that's all we have. Now we're going to go through and we're going to circle the ones that are the same. Okay, let's scroll up a little bit. So we have 1's the same. 2, 2, nope, no 2 there. 3, 3, 3, we have 3's that are the same. We have 4, nope. 5, nope. 6, nope. 9's, we have 9's that are the same. 12, no. 15, no. 18, no. 45, 36. So we have 1, 3, and 9. So my answers then, Ryan can put either 1, 3, or 9 animals in each row. All right, let's take a look at a test question. All right, so we have this table here, and it tells us that there's 30 oil paintings, 24 photographs, and 21 sketches. Now let's take a look at our problem. We've got the museum is hosting a show for July that features all the oil paintings by different artists. All artists show the same number of paintings, and each show will show more than one painting. How many artists could be featured in the show? All right, let me switch over to dual page so that I have a blank page. All right, so first thing you need to do I need to figure out common factors? I have 30, 24, and 21. Do I need to figure out common factors for these to answer this problem? No, and let me tell you why. Because all it's asking for is oil painting. Okay, oil painting. So be paying attention when it tells you to do something or to focus on something when you're doing a word problem. So oil paintings is 30. So all I need to do is figure out the factors of 30. I've got 1 and 30. 2 goes into 30 15 times. 3 goes into 30. 3 times 10 is 30. 4 doesn't go into 30, but 5 does. 5 times 6. And I believe that's all for that one. Okay, so would my answer then be 1, 2, 3, 5, 6, 10, 15, and 30? No, the answer would be no, because it asks us to do one thing. It asks us to do something. Okay, it says more than one. All artists show the same number of paintings, and each will show more than one painting. Okay, so that automatically takes those off. Okay, so 1 and 30 cannot be part of it anymore. Then that leaves my answer. So 2, 3, 3, 5, 6, 10, and 15 is my answer. Okay, so pay attention when you are looking at the word problems, okay? That you probably wouldn't have even caught that it says more than one painting, so one can't be an option, and artist, so 30 couldn't be the option. Takes out that factor pair, and then it's only talking about oil paintings. Okay, second part of the problem. The museum wants to display all the art pieces in rows. Each row is the same number of pieces and the same type of pieces. How many pieces could be in each row? Okay, now here's the second part of the problem that we need to figure out. All right, so now we're dealing with all of the numbers, right? It's saying all of the art pieces in a row, all of them, not just oil paintings. Now I've got all of them. So now I'm going to go back to finding factors. I have 30, I have 24, and I have 21. All right, so I have 1 and 30, 2 and 15. We already figured these out. 3, I should have just left them up there. 3 and 10, 4, 5, and 6. Okay, and then we have 1 and 24. 2 and 12, right? Because 2 can go into 24 12 times. 2 times 12 is 24. 3 and 8. 4 and 6. And that is it. 21, 1 and 21. 21 is not even, so 2 can't go in, but 3 can. 3 times 7. 4 can't go in, 5 can't go in, 6 can't go in, 7 goes in, 8, 9, 10. Okay, that's all that can go in for 21. All right, now I'm just going to go through and I'm going to circle the things that are the same. So I have 1. Let's see. 2, nope. 3 is yes. 4 is no. 5 is no. 6 is no. 7 is no. 8 is no. 10. Nope. Okay, so it looks like just 1 and 3 can be in each row. So 1 and 3. Okay. So you can either have 1 in each row or 3 in each row. But that's all you can have in order to be able to make sure that all the paintings are done in rows. All right, let's take a look at our homework. Let's see. Okay, so we have similar type of problems. You're going to be looking for finding the common factors of the numbers that are in there. Simon is making wreaths to sell. He has 60 bows, 36 silk roses, and 48 silk carnations. He wants to put the same number of items on each wreath. All the items on a wreath will be the same type. How many items can Simon put in each wreath? Okay, so what am I going to do? I'm going to go through and I'm going to find the common factors for that. So I've got 60, I have 36, and I have 48. All right, so we know 1 and 60. 60 is an even number, so 2 is going to go in there. You can do the division, but for sake of time, I'm going to tell you 2 times 30 is 60. 3 can go in. 3 can go into 6 2 times and then add 0. 4 can go into 60. Okay, 4 can go into 60. 4 goes into 6 one time. And then 2 carried over 4 goes into 25 times. So 4 times 15 is 60. 5 can go in, right, because it ends with a 0. 5 goes into 6 one time. Carry the 1 over to a 10. 5 goes into 10 2 times, so 12. 6 can go into 60. 6 times 10. Okay. And I believe that is all she wrote for 60. So let's fix that. All right, so 36. So we have 1 and 36. Even numbers, so 2 can go in. 2 can go into 3 one time. Carry the 1 over to 16, so that'll be 18. 3 can go into 36. 3 goes into 3 one time. 3 goes into 6 2 times. 4 can go into 36. 4 times 9. 6 times 6, and that is all for 36. So we have 1 and 48. 48 is an even number, so 2 can go in. 2 can go into 4 2 times. 2 can go into 8 4 times, so 2 times 24 is 48. 3 can go into 48. 3 can go into 4 one time. Carry 1 over to 18. 3 goes into 18 6 times, so 3 times 16 is 48. 4 can go into 48. 4 goes into 4 one time. 4 goes into 8 2 times, so 4 times 12 is 48. 5 won't work because it doesn't end with a 5 or a 0. 6 can't go into 48. 7, I'm a liar. 6 can, right? 6 times 8 is 48. I didn't give you a chance to find that out. 7 cannot go into 48. 8 obviously does, and that is it for that. So now I'm just going to go through and I'm going to circle the common factors. So my common factors then are 1, obviously. Always. 2, they're all even numbers, so 2 is going to be a common factor. 3 is common. 4 is common. 6 is common. Let's see, 8, no. 9, no. 10, no. 12 is common. 15, no. 16, no. 18, no. 20, no. 30, no. 60, no. So those would be the numbers that we would list for our commons. So it would be 1, 2, 3, 4, 6, and 12. All right, so let's see here. How many do we have left? Okay, that leaves you with 3 problems to do on your own, which I'm sure you can handle. Your WSQ is obviously to finish the practice book page, and we will see you in the morning.